degrees. Okay, we're going to look at the proof here. You know, they ask us to prove, and if you look in the memo, I think they have 3 or 4 or 5 different ways you can prove this. They say use the diagram to prove the theorem that says that QST, the angle between the tangent and the chord, is equal to this angle R. Well, here's one way you can do it. You can make this construction. Connect O to T and connect O to S, just like that. So you can do that connection right there. So that's a construction. You construct the radar, OS and OT. That's your first thing. Now you can say that I should say OSQ or QSO. That's not quite right. So I'll fix it right now and say, oh, whoa, stop it. Okay, we'll say that OSQ, angle OSQ, that angle OSQ is equal to 90 degrees because a tangent is always perpendicular to a radius. So that angle there, OSQ, is equal to 90 degrees, And okay, that's that part. OSQ is equal to 90 degrees. OSQ, we know that's 90 degrees. Because the tangent is perpendicular to the radius. Now let's look at another thing. Then you let certain angles, OTS, you let that equal X, and you let that one equal X, OST, you let those two angles equal X. And why can we do that? Because there's equal angles opposite these equal radii. Then you could say, you could also say that QST now, because you know that's 90 degrees, QST must be 90 minus X. QST must be 90 minus X. Okay, so we got all of that. QST must be 90 minus X. Hey, we're almost there now. Do you know, this has to add up to 180. So this angle at the center must be 180 minus X. And you know what? So TOS must be 180 minus 2x, rather. This angle at the circumference is half as big. Well, then that's the end of it, really. R must equal 90 minus x, because the angle at the center is 2 times the circumference. Well, we just proved that those two angles are the same thing, 90 minus x. Now, there's 4 different ways of doing it. In the exam, you can look at 4 different proofs, different ways of proving the tan chord theorem. But that's one of them right there. Okay.